Hello friends, today we will learn about the kinetics of reaction in solid state. I am Dr. Mansoor Maulavi, Professor Ramakrishna More College, Apodi. First, we will look the classification of solid state reactions on the basis of phases of reactant. In homogeneous reactions are classified on the basis of the order and the molecularity of the reaction. Means first order reaction, second order reaction, third order reaction. But in case of the solid state reactions, it is not the case. Solid state reactions are classified on the basis of the phases of the reactant. So first type of the solid state reaction is the solid are directly converted into product like decomposition reaction. Second is the solid react with the gas to form product. Third type is the solid reacts with solid to form product. Fourth type is solid react with liquid to form the product. And last, fifth, is the reaction on the solid surface. We will look the examples of solid state reactions. First type is the solid is directly converted into product. Example is decomposition reaction of nickel oxalate. Whenever the nickel oxalate is heated at high temperature, it is converted into nickel carbonate and the carbon monoxide gas. Other example can be the lime calcium carbonate. Whenever heated at very high temperature, it is converted into calcium oxide and the carbon dioxide gas. Second class of the solid state reaction is solid react with gas to form the product. Here, example is the corrosion of the metal in atmosphere. Different metals like zinc, magnesium, etc. reacts with oxygen of air to form their corresponding metal oxide. And this reaction corrodes the metal. Third class of the solid state reaction is solid reacts with solid to form the product. Here, magnesium oxide reacts with the Fe2O3 to form MgFe2O4 solid. So it is also example of the formation of solid-solid solution or complex solid metal oxide system. Fourth type is the solid reacts with the liquid to form product. Here example is the formation of intercalation compounds. Last type is the reaction on the solid surface. Here, the hydrogenation reaction on metal surface. Then we will look the classification of solid state reaction on the basis of the mechanistic basis. In case of solid state reaction, there are different phenomena take place like nucleation, then diffusion, etc. On that mechanistic basis, solid state reactions are classified in first type is the nucleation. The formation of active sites on the surface of solid is known as the nuclei, and these nuclei are responsible for the reactivity of the solid surface. So formation and growth of the nuclei are considered to be the rate determining step in case of the solid state reaction. Second type of solid state reaction on the basis of mechanistic basis is the geometrical contraction. So the formation of progress of the product layer from the surface to the inner crustal is considered to be the rate determining, and it is different for various type of crustal morphologies. Third type of solid state reaction is the diffusion. Whenever the one of the reactant is gas or the product is the gas, then diffusion of this gaseous reactant or the product take place through the solid surface. So rate of diffusion is also considered as the rate determining step in case of the solid state reactions. And last is the reaction order. Unlike homogeneous reaction, the order of reaction is also the rate determining step for some of the solid state reaction. So rate law for such reaction is based on the consideration of homogeneous kinetics. Now we look the rate determining steps of solid state reaction. On solid state reactions on the surface of solid, different phenomena take place like adsorption, disadsorption of gases, then the chemical reaction on the atomic scale on solid surface, nucleation of new phase on solid surface, and the diffusion or transport phenomena of gaseous reactant or product through the solid. So these steps are considered as the rate determining step in case of the solid state reaction. In case of homogeneous reactions, the rate determining steps can be formation of reaction intermediates or the formation of transition state, but it is not the case for solid state reaction. These are the steps, rate determining step in case of the solid state reactions. Now, we will look the important topic of solid state reaction is factor affecting the rate of reaction in solid. The first factor is the size of particle and the surface area. So as the size of particle increases, surface area decreases, and hence rate of solid state reaction decreases. And as the size of particle decreases, surface area increases and the rate of reaction increases. So it is showing the big particle with smaller surface area shows the slower rate of reaction, while the small size with larger surface area shows the faster rate of reaction. Second factor is the physical characteristic of the solid surface. So in case of solid state reaction, the solid that is reactant, there is an interaction or interface between the reactant and the product that is referred as the topochemistry of the reaction. Based on that, in some instances, it is possible to observe the advancing boundaries between the reactant and the product, and it is proceeded by the appropriate microscopic technique. If you have the suitable experimental technique for the observation of reaction on the solid surface, so under such cases, we can see the formation of boundaries between the reactant and the product means the whenever the product is converted, whenever the reactant is converted into product, then there is formation of boundary between reactant and the product. So this is the physical characteristic of the solid surface. Based on that, third factor is the rate of nucleation. So formation of active sites on the surface of the solid surface are called nuclei. Nuclei are the active sites on solid surface, and these nuclei or active sites are responsible for the reactivity of solid on the surface. So rate of reaction in case of solid are commonly depend on the formation and the growth of active sites, and that active sites are called the nuclei. For some of the kinetic models, the geometric nature of the growth of these nuclei determines the form of the rate law for the reaction. For example, the nucleus that grows in two dimensions gives rise to different rate than that of growing in one or three dimensions. So this is it is observing the formation of active sites on the surface of the given solids. Next factor is the rate of diffusion. So in case of the gaseous reactor or the gaseous product on the surface of solid, the diffusion of such gases take place through the solid surface. So rate of solid gas reaction is depend on the rate of diffusion of gas through the product. Lattice defects are also important because these defects promotes the diffusion of this gaseous material, and hence reactivity in general of such solids are depend on the high energy centers in the solids. Surface defects increases the reactivity of the solid state by promotion of the diffusion of gaseous product through them. The next factor is the effect of activation temperature. To increase the activity of the solid surfaces, it is very important to heat the solid at very higher temperature. So because of this heating the higher temperature, the reactivity of material increases due to change in phase transformation, that is known as the head wall effect. Phase transformation means at higher temperature, the one crystal system of solid is converted into another crystal system, that is known as the phase transformation, and at higher temperature the phase transformation is very common. Because of this phase transformation, at higher temperature, the solid undergoes some type of crystal rearrangement. It is clear from this figure that this hexagonal close packing crystal structure is undergoing phase transformation into the phase centered cubic crystal system. This phase crystal cubic system is converted into the body center crystal system. So one type of the material, solid material, can exist in different crystalline form, which are known as the phases of the material. So because of change in the phase of the material due to change in temperature, the difference in the reactivity of the solids are observed. Then the generation of defects at very high temperature. Whenever the solids are heated at high temperature, the such treatment of sample may cause the surface damage in the form of formation of the cracks, pores, such which is known as the surface defects. And these surface defects can alter the rate of reaction of the sample. Sometimes it is also possible to heat the sample to a temperature below that at which it undergoes the reaction, but which is sufficient to cause some of the annealing to occur. This process can remove the part of defects and thereby lower the subsequent reactivity of the solid. It is meaning that the reactivity of solid is not only depend on the heating at high temperature but also depend on the rate of cooling of the material. Whenever the solids are heated at very high temperature and is suddenly cooled, because of that sudden cooling, the surface defects increases, that increases the reactivity of the material. Such process is also known as the annealing. But in case of the slow cooling, that damage or the defects of the material can be removed or the repaired, so it can give the lower the reactivity of the solid. So the reactivity or the rate of reaction on solid surface is depend on the activation temperature and the rate of cooling.